All right. Hello, everybody. Today's lesson is about factoring, factoring polynomials. So I want to go over each of the assignments that you have on, and there's 6 of them today. Most of them are factoring. So this is helping you to factor, identify quadratic patterns, factor high degree polynomials. And these 2 are actually multiplication, but it's smart to do the multiplication first because what we're really interested in is the reverse process, which is factoring, right? So we'll start off with a difference of squares here. All right, so a difference of squares is something, here, let me just write this out, difference of squares. All right, so you see basically you've got 4 in this problem here, 4 plus 3 c to the 5th times 4 minus c, 3 to the 5th. Right, the difference of squares looks like something like this, a squared minus b squared. All right, so where you have 2 perfect squares, and the difference part is, where they're being subtracted. So that's a difference of squares. So if I have something like a plus b times a minus b, and I want you to multiply that, let's just go through the process. So we would do a times a, which is a squared. We would do a times minus b, which is minus ab. And then we would do b times a, which is plus ab. And finally, b times minus b, which is minus b squared. And as you can see, these 2 in the middle just cancel each other out, leaving you with a squared minus b squared. So that the product is what we call a difference of squares. All right, so what you've got here then, well, before I do this problem, let's just talk about the shortcut then, the obvious shortcut, right? If when you do the difference of squares, if you notice, the only thing that survives the process is this product, right? And this product. The other 2, this a times minus b and this b times a, they just cancel, and it's always true with a difference of squares. So we can come up with a shortcut then, and this just do a times a and b times negative b. And you should always end up with a minus sign because you're at the end here, you're multiplying a positive 2 and a negative. So this problem here on Khan Academy, where you have 4 plus 3c to the 5th times 4 minus 3c to the 5th. I can go through the whole process, but really, the only things I need to worry about are multiplying these 2 together, which is 16, and then multiplying these 2 together, right? Because when I do these 2, that's going to be what, negative 12c5? And then do these 2, that's going to be positive 12c5. They're just going to cancel out. So 4 times 4 is 16, minus 3 times 3 is 9, and c to the 5th times c to the 5th is c to the 10th. All right, so I can take that shortcut to get the answer if I recognize that this is just going to be a difference of squares. So let's see, 16, take away 9c raised to the 10th power. There we go. Okay, and these are all the same. I'll just do this one more. So 3 2x to the fourth plus 3x cubed times 2x to the fourth minus 3x cubed. All right, so I just do the first. Since they're obviously a difference of squares, you can see they look identical, except this one's plus, this one's minus. That's how you recognize the difference of squares. So I multiply these two, I get 4x to the 8 minus, this would be 9x to the 6th. 4x to the 8. Oops. 4x to the 8 minus 9x to the 6th. Looks good. And we're done. All right. So that is, here, I'll blow that up in case you want to copy that. So that is a quick lesson on difference of squares. What we're going to really be interested in is working backwards, right? So if I were to give you a squared minus b squared, could you reverse the process and go back to a plus b minus b? Same here. Would you know that 16 minus 9c to the 10th factors to 4 plus c to the 5th times 4 minus c to the 5th, right? That's the important thing, is that you can work it backwards. All right. So let's get rid of that. The next one is special products perfect square. Perfect square. So we're talking about perfect, often called a perfect square trinomial. All right, perfect square trinomial. Let's look at the same situation where I did a plus b times a minus b. The difference would be, instead of a plus b and then a minus b, you would have a plus b and another a plus b. Right. So and that could also be written, you might see it as just a plus b squared, same thing. So when I multiply these, let's go through the process here. So I got a times a, which is a squared. And then I've got a times b, which is ab, so plus ab. And then I've got b times a, which is another ab. And then b times b, which is b squared. All right. Now these two do not cancel out, they add up. So you end up with a squared plus 2ab plus b squared. All right. All right, so the shortcut would be then, if you have something like, I'll just make something up here. Let's say you have 2x squared plus 3x, and you want to square that. All right, well, this is your a, right? So this is like your a, and this is your b. So I know that if this is like a template or a formula, when I multiply this out, all I have to do is square this term. So if I square this, I get what? 4x to the fourth. That's what I get when I square that. Okay, and then this middle one is just the product of these two doubled, right? So if I multiply these two together, 2 times 3 is 6, right? So you're going to double that to 12. I'll just do it like this. So leave the 2 out there, and I'll do it like this, okay? So 2x squared times 3x is what, 6x to the third? And then the last term is just b squared. So you would square this and be 9x squared. Okay, to simplify it a little more, that's just going to be 12x cubed in the middle. So 4x to the fourth plus 12x cubed plus 9x squared. All right. So that's a perfect square trinomial. Now you could have a minus sign in here. So let's say I had instead a plus, they both are always the same. So instead of a plus b, maybe it's a minus b and another a minus b. That's going to be the same, except that sign right there is just going to be the opposite, right? Because when you do a times a, you still get a squared. And when you do minus b times minus b, you still get plus b squared. But in the middle, you have a negative when you go here and another negative when you go here. So that's going to be 2ab in the middle. So the only difference between a plus b squared and really what is a minus b squared is instead of that middle term being positive, that middle term is going to be negative. All right, so let's look at one of the problems on Khan Academy here. So we have 9 into the 7th minus 1 squared. Okay. Now, if you want, there's nothing wrong with doing 9 into the 7th minus 1, and then just doing another 9 into the 7th minus 1 and multiplying it out. You don't have to use the shortcut, but again, the point of understanding this shortcut is to help you work the process backwards. All right? So it's good that you know it if you learn it well. So when I multiply these two together, actually I could just take it from here. I don't even need to write this out. This is going to be this times itself, right? So that's going to be 81 into the 14th. Okay, there's a minus sign here, so it's going to be minus something. To figure out minus what, you just multiply these two together, which is 9 into the 7, right? Because 9 into the 7 times 1 is just 9 into the 7, and then double that, so that's 18 into the 7. And then the 1, which is going to be 1 times 1, which is 1. And it's plus 1. As you can see, if you multiply it right here, you would get positive 1. All right. So let me type that in. Minus 18 into the 7. Okay. All right, and that's how all those work. Okay, let's look at another set. So we've got factor polynomials using structure. I'm not sure what order to go in here, so I'll just take them in the order that they're in. Factor higher degree polynomials. Let's see what this is. All right. Higher degree meaning, I guess, you've got this degree is degree 5. Let me write this out. This is factor higher degree. Okay, so number 1, we got 3x to the 5th minus 75. 5 x to the third. Okay, so when you're trying to factor a polynomial, there's kind of like a strategy to approaching it. I guess the first thing you want to look at and see, do these two terms have anything in common? And if they do, you want to factor that out as the greatest common factor. So you can see here that there is a GCF, the greatest common factor, because 3 goes into both of these numbers, so 3. And x cubed goes into both of these, right? This has an x cubed, and this has more than x cubed. So that means I can factor out a 3x cubed. And let's see what that leaves us with. So if I factor out a 3x cubed from this, I'm left with x squared. And you want to check that you did that correctly by just multiplying back and make sure you get this term, right? So 3x cubed times x squared is, in fact, 3x to the fifth. Okay, then you got minus here. Right now, what is this going to be? Well, 3 times what is 75? That's 25. And you took out the x cubed, so it's just that. All right, so now I've got two factors, right? 3x cubed is a factor, and x squared minus 25 is a second factor. Will this factor more? And as a matter of fact, it will. If you notice, this is a difference of squares, right? It's a difference of squares. So this would be 3x cubed, which is the first factor, and x squared minus 25 factors to x plus 5 and x minus 5, right? Because if you multiply x plus 5 to x minus 5, you get x squared minus 25. All right, so now this is fully factored, so this is your final answer. And you want to, when you do these, you want to make sure you factor completely everything that you can factor. Make sure you do factor it out. So x cubed, 3x raised to the third times 5 times 5. All right, that works. Where that is bigger if you need to copy that down. Okay, let's look at another one. All right. X cubed plus 7x squared minus 5x minus 35. Okay, you have 4 terms here. First, same thing. I want to look. Do they all have something common? They don't even all have an x, right? X, this one has an x, this one does not. So you can't factor out an x. You can't factor out a 7 because the 7 won't go into them all evenly. You can't factor out 5. So there's no GCF here. All right, now typically when you have 4 terms, there's some way to split them up into groups, right? So for instance, let's just play around with this for a minute. So I'm going to group these first 2 terms. Okay. And I'm also going to group the second 2 terms. Now here you have to be careful because you're adding in parentheses, right? So that minus sign. But if I group this like this, 5x, then this becomes a plus 35. Okay, so let me zoom in. So try to understand if you're confused. Let me go back. That negative gets distributed, right? So if I were to drop these parentheses, that negative would get distributed here, which would make that a minus 5x. And it would also get distributed there, which would make that a minus 35. Okay, now if you notice, even though there's not a GCF for the whole thing, there is a GCF here for these two, and there's a GCF here for these two. Right? So the GCF for these two is x squared. because they both have at least x squared. So when I factor out x squared, this is just x, and this is just 7. All right, minus. These two have 5 in common, so I can factor out a 5, right? Then that leaves me with what? X plus 7. All right, so now what I've done is I've turned this into a situation where you have this expression and this expression that have x plus 7 in common. So that means that you can factor out an x plus 7 out of this whole thing. So if I factor out x plus 7, think of x plus 7 as just one thing, okay? That's going to leave me with, for this expression, it just leaves me with x squared. And over here, it just leaves me with the minus 5. All right, so now I've factored this into two binomials. Now this here is almost a difference of squares, except, 5 is not a perfect square, right? If that were 9, then I could factor that even further. I guess you could argue you could factor that to the square root of 5, but I don't think they want that here, right? So, for instance, what I'm trying to say is I could keep going since you turn that into like x plus the square root of 5 times x minus the square root of 5. Because I think if I multiplied x plus the square root of 5 to x minus the square root of 5, I would get what? X squared. And then since this is a difference of squares, when I multiply these two together, I just get minus 5, right? But I don't think they want any factors with irrational numbers. So I'm going to assume that this is the best factored answer here. So let's try it out and see if it works. So this is x plus 7 and x squared minus 5. It'll take this. All right. Okay. Here you've got two factors, and they want you to factor it even more. So let's see, x squared minus 5x plus 4, and x squared minus 9. Okay. Now, x squared minus 9, that's a difference of squares. So I know it's going to factor to x plus 3, x minus 3. Over here, I think this will factor. Remember, when you have just a typical trinomial like this, it's quadratic, and you want to factor it, you're just looking for two numbers that multiply to 4 but add up to -5, right? So two numbers that multiply to -4 are -4 times -1, right? That multiplies to 4. But they also have to add up to -5, so -4 plus -1 is -5. So that's what we want then to make this factor. So this will factor to x minus 4 times x minus 1. Right, so now we've got these four factors here. Right, so we broke this trinomial down into these two factors. We broke this binomial down into these two factors. So we have, sorry, scoot that over there. So minus 4. 3. Go. Okay, let me zoom in on that a minute in case you need to copy it. All right, let's do one more of these. So now I've got 2x to the 4th plus 4x cubed minus 30x squared. All right, so do they have GCF? And they do, right? They're all even, so that means that I can factor out 2. And they all have at least x squared, so I can factor out x squared. All right, now for this first term, that leaves me with just x squared, because 2x squared times x squared is that. For this term, that leaves me with 2x, right? 2x squared times 2x is 2x cubed. And for this term, that leaves me with 15. Okay. Now, will this factor? So we're looking for two numbers that multiply to negative 15, but add to 2. Right? We want two numbers that multiply to negative 15, add to 2. I bet you can guess what those are. 5 and negative 3, right? 5 and negative 3. All right, so this factors to x plus 5 and x minus 3. So 2x squared times x plus 5. All right, so that one's a little more difficult, right? You have to know your factoring pretty well to get through this set. I really encourage you to do it. Try to learn this. If you're not doing well on it, do this assignment several times until you get it. You know, it's all right to cheat with math programs to see if you're right before you answer if you want, but in the long run, it's not going to do you any good. Especially if you're going into calculus, you really need to get a handle on the mechanics of factoring these types of expressions. All right, let's look at this next one. Identify quadratic patterns. Slow. All right, so basically you're looking at an expression that's complicated and trying to figure out, you know, does it match a certain pattern, right? So for instance, in this problem, we've got x minus 2 to the 4 minus y plus 3 to the 4. Okay, now if I just temporarily, and the letters they're using here are u and v, so I'll use u and v as well. Let's let u represent x minus 2. All right, and let's let v stand in for y plus 3. If I do that, if I make these substitutions, then this becomes u to the 4th minus v to the 4th, and that's a perfect square, right? That's a perfect square. As a matter of fact, I could do a little more. I could let this be squared here and let this be squared. And if I do that, then that's still 4, sorry. then this would just be, right, this would be 2, and this would be 2, I think. All right, so does that make sense? So what I'm looking at is, let's see, which pattern can we use to factor these expressions? I think we could do that, right? Because this is a difference of squares. Even if I just leave it alone, so let me just leave it the way it was. This is a perfect square, right? The square root of u to the fourth is just u squared, and that's a perfect square, and that's a difference. So that's a difference of squares, right? So I don't even need these. All right, so to me, it seems like this would work. It says u and v are either constant integers or single variable expressions. U and v are either constant integers. Let's see what happens when I click that. That's correct. Okay, so basically I see this expression is a perfect square because it's to the fourth power. And this expression is a perfect square because it's to the fourth power. And you're just subtracting them, so that's just a difference of squares. Okay. So confusing. This one, it's definitely not a difference of squares. This is asking, could it be like a perfect square trinomial? So let's check that out. So is it possible that it's A, u plus v squared? We have x to the fourth plus 3x squared y plus 9y squared. Well, you remember, if it's a perfect square trinomial, then it should factor down to the square root of that one, which is x squared, plus the square root of that one, which is 3y. It should do that. Does that work? Now, the way I can check it is I can multiply these two together, right? But then you got to double it. So when I multiply these two together in the middle, that's 3x squared y, but you have to double that, right? Which would be 6. So that would need to be, this is not equal, that would need to be a 6 for this to be a perfect square trinomial, right? So no. It's close to this one, but it doesn't quite work out. So we can't use either of those patterns. All right, this almost looks like a perfect square trinomial, except the problem is that's a 5, right? That would need to be an even number for it to be a difference of squares. And since that's an even and that's an odd, there's no way to ever make it one. So I don't think it's going to be either of those. It certainly can't be a perfect square trinomial because it's only a binomial. So no, can't be either. All right, and remember that's because that power's odd. Okay. All right, so here, let's see, we've got x minus 3 squared minus 10 times x minus 3 plus 25. Well, it looks a little confusing like this, but let me just substitute. I'm going to let, I don't know, let's let the letter U. I better not use U because they use it. So how about W? They don't use W. I'll use W. So let's let W represent, just for a minute, x minus 3. We just want to make it look a little simpler, right? So I'm going to replace these with w. So this would be w squared minus 10 times w plus 25. Okay. That looks like a perfect square trinomial, right? Because that's a perfect square. The square root of that's w. And that's a perfect square. The square root of that is 5. You got a minus here, so that would have to be minus. Is it possible it could be this, which would just be w minus 5 times w minus 5? And I think it is, right? So because if you square that, you get that. If you square that, you get that. And if you multiply these two together, you get minus 5w. And when you double it, you get 10, minus 10w. So it works. So this is in the form of a difference. No, not a difference of squares, a perfect square. So this one. All right, so that one's kind of tough. All right, let's look at the next set. Factorization with substitution. And again, this should all be review. If it isn't review for you, it feels new, then you need to practice this a lot more. And if you need extra help on it, please just don't hesitate to ask, and we can set up a time where I can help you out. All right, so this one is factorization with substitution. So it says we can factor the expression u plus v squared, where u and v are either constant integers. All right, that's the same thing as the other set. What are u and v? Okay. So 16x cubed plus 24x cubed y to the fifth plus 9y to the 10th. All right, let's see. We have 5 choices. Okay. So it looks like what they're saying is this is a difference of square. This is a perfect square trinomial, right? And if it is, then what substitutions are u and v if we wanted to make it look like this? So let's start off by saying, okay, oh, that's 6 power. That helps. Okay, that's a 6 power. So what's the square root of this? That would be 4x to the third, right? Okay, and the square root of this, square root of 9 is 3, and the square root of that is y to the fifth. They're all positive, so that would be positive. And that would be your factorization. Now let's make sure that the middle term comes out to be 24. Remember, you multiply these two terms together, which gives you the x cubed y to the fifth, and gives you 12 in front. But then you have to double it, which gives you 24, so we're good right there. So that is your u, and that is your v right there. So right there should be good. Scoot that over a little bit. Oh, there's a lot of choices. Okay, let's see. Oh, then it wants me to actually factor the expression. Interesting. Okay. So that means I just put that in. Let's try it and see. So 4x raised to the third plus 3y raised to the fifth. And out here, I do square. And I hope it takes it. Yes. All right. So let me blow that up for you in case you need to copy that down. question. All right, now this one they're saying is a difference of squares. So let's see. X plus 2 squared minus 25 y to the 4th. All right, so it's breaking it up, into this right side and this side. So we're going to let x plus 2 be the u, and we're going to let, I think we need, so u is x plus 2, right? And v is the square root of this, which should be 5y squared. Right? Because of u, so it would look like this. U is x plus 2 minus b, which is 5y. Squared is squared, and that's what gives you that 25 y to the 4. All right. So let's see. So u is x plus 2, and y is 5. V is 5y squared. This one, right there. All right, and then what does it factor to? Well, let's see. So if you factor it, it factors to u plus v times u minus v, right? Okay, so now we'll just substitute back in. So u is really just x plus 2 plus v is 5y squared times u again, which is x plus 2, minus v, which is 5y squared. All right, let me blow that up so you can let me just go over the whole process one more time. So I recognize there's a minus sign, and you got this thing squared, and you've got this, which is not squared, but you take the square root of 25, and you take the square root of this, right? So we can let u be x plus 2, just for temporarily, and we can let v be the square root of this whole thing, which is 5y squared, and then rewrite this whole thing as u squared for the first part minus this squared, right? Now, u squared minus v squared is just a difference of squares, and that factors to this. Then all I did was I went back and I replaced u with this, right? And I replaced v with this. And I did the same here. I replaced u with x plus 2, and I replaced v with 5y squared. All right. Let's see. Parentheses. X plus 2 plus oh, that's right. Okay. Times x plus 2 minus 5y. That should do it. Okay. All right. And so this time it says we can factor the expression as u minus v squared, which is a perfect square trinomial. I think I'll stop there, and hopefully you got it from here. Okay, let's go to the next one. That was factorization with substitution, I believe, wasn't it? Let's see. Yeah, that was factorization with substitution. So factor polynomials using structure. So basically, it's doing the same thing we just did, but without the hints, right? So we've got 9m squared plus 30mn plus 25m squared. And I don't see a common factor. 3 goes into that, but not that. They don't all have an m. They don't all have an n. So I think what we got here is a perfect square trinomial, right? Because this, if you take the square root of that, you get 3m. 3m. Good grief. 3m. If you take the square root of this, you get 5n. They're all plus, so we'll put a plus in there. So I think it factors to that. Now, we just got to check that the middle term is what it's supposed to be. So when you multiply these two together, you get 15mn, and then you got to double it, which gives you 30mn. So that's it. So that is going to be plus 5n and outside squared. That is a difference of squares, right? That's a difference of squares. Let's see. 16x squared minus 49y squared. So you can take the square root of that, which is 4x, right? You can take the square root of that, which is 7y. And if you remember, because of the difference of squares, it factors to this, but also the same thing again with the opposite sign. Okay, let's make sure it works. So when you multiply these two, you get that. When you multiply these two, you get what? 28, right? 28xy. And this one gives you negative 28xy, so they cancel. And then this two together make negative 49y squared. So that's it. X minus x. And again, that looks like, I'll do this one last one. Okay, that looks like a perfect square trinomial. So we have 16n squared, into the sixth, plus 40 into the third, plus 25. I don't see any common factors. So the square root of that is 4 into the third. The square root of that is 5. They're all plus, so plus squared. So let's see if that works in the middle. 4 into the third times 5 is 20 into the third. Double it to get 40 into the third, so that it works out. All right, I won't bother putting it in here. It's right. I think that was it. Is there another one? So that was using structure. Yeah, that's it. All right. Thanks so much for watching. I hope this helps. Have a great day.